I don't know how many folks drove in from the Boston area today, but you just hit a point in central Mass and like it starts raining, then you go another 20 miles, now it's snowing. So different world out here, now it's fine. Thanks for hanging in there. I'm excited to be the wrap up for the day. So my name is Gabby, and I'm an industry strategy manager within the design and manufacturing group at Autodesk. So it's been really fascinating being here today and listening to the other presenters. So we're more on the FANUC side in terms of our business. We're not a startup. I'll go into who we are a little bit later, but just about me first. So my background's in mechanical engineering. And prior to Autodesk, I worked at a handful of startups in the Boston area in clean tech and material science as a mechanical design engineer. And then about 5 years ago, I moved into Autodesk into the education group. So it was cool to see, I think Joe was his name earlier, talking about all the stuff FANUC does with education. We have a really similar program. We try to, we work with thousands of schools across the country, trying to help them better teach design and manufacturing. We give away all of our software for free to education, which is a pretty big thing. I don't know how many folks in the education group have used Autodesk software. We work with MIT quite a bit, and we have certifications and all these things, and a whole 100-person business group working on education at Autodesk. So it's very near and dear to me. And then I first sort of encountered manufacturing working at startups. You have to wear many hats. So I would design something, and then the next task was figure out how to make it. So we worked out of a space in the Boston area. A couple of companies I worked at called Greentown Labs, which I don't know, maybe folks have heard of it. But it's basically a startup incubator space, and they had a bunch of CNC machines and sheet metal stuff. And I would go in and just sort of learn how to use a CNC machine and make our stuff. So I made prototypes on there, and that was sort of my first foray into a little bit of manufacturing. And I've tried to stay close to it ever since. And it's great to be here and talk to customers and listen to all the things you've said over the course of the day. So, so today we're going to do, here's a quick run through. First I'm going to introduce Autodesk and go over some of the industry trends. I'm going to breeze through that part because it's a lot of repeat from what other companies have talked about in terms of trends that they're seeing. And then I'm going to dive into two solutions. So Autodesk has a portfolio of over 90 software solutions. Not all of them are design manufacturing, but I'm going to talk about two today. One called Autodesk Fusion, which is it's a design and make platform. And I'm going to specifically talk about some CNC programming automation. And then I'm going to talk about our MES system, which we talked about MES a little bit earlier with Bill's presentation, and talk about digitizing production. And finally, we'll do some Q&A. So a little bit about Autodesk, if you're not familiar. We're a technology company founded about 40 years ago. So who's heard of Autodesk? Great. Who's used Autodesk stuff? What have you used?
Inventor, Fusion 360, Mechanical Desktop many years ago.
Awesome. Yeah? Anyone else? AutoCAD. Who's used AutoCAD? Raise your hand. Okay, basically everyone. Yeah. So, we're really trying to, we still love AutoCAD. It's a huge part of who we are. We're also, moving towards a new, cloud-connected platform business. So still supporting AutoCAD, still supporting Inventor, still supporting our flagship products all across our industries. But what I'm talking about today is really the direction that we're putting a lot of our innovation into, which is a platform called Autodesk Fusion for design and manufacturing. So anyway, just finished on this slide, right? So we're a large company. We have 96% of our business is in recurring revenue. We have about 12,000 full-time employees, like 15,000 including contractors, and over 12 million monthly education users globally. So we have three main business segments, and millions of people over the past 40 years have trusted our technology to transform how their products are made. And in the process, we like to think that we've transformed what can be made, to be, starting with AutoCAD in 1982, really moving everything away from paper, pretty much transformed the industry. So our portfolio of solutions span the entire set of capabilities that professionals in these 3 segments need to achieve business outcomes. So for architecture, engineering, and construction, that's where AutoCAD sits, where our architectural products sit, where our construction products sit. Design and manufacturing is where manufacturing and factory and product solutions sit, and then media and entertainment, which is like probably the most separate side of the business, is over there. But I'm sure many of you have seen movies that have used our stuff. And one more note, so what I think really differentiates Autodesk, I mean, there's a lot of companies that do make products in all these sectors, is that we span the entire design to make life cycle. So we have software that designs things like this, things like, this. We have software that makes those things, so it can, create molds and tool paths and simulate manufacturing for these objects, right? And then on the other side, we have software that designs places, so designs buildings, designs MEP systems, so mechanical, electrical, piping systems, or plumbing systems, designs structures, buildings, infrastructure, roads, and then we have software that can build those things. So design things, make things, design places and build places, and then we also have software that operates those facilities. So to be able to span the entire process with our solutions, and most of which connect to each other across that process, puts us in a pretty unique position. So now you know a little bit more about us, hopefully, although it's awesome to see so many hands that people have used us. Hopefully you like us. So this is the part I'm going to breeze through, talking about trends affecting manufacturers, and I'll stop a little bit in the middle. I'm curious how many of these are relevant to you. So, we're certainly in turbulent and, very, very interesting times, right? So we're seeing our customers concerned about geopolitical unrest, financial volatility, the lasting impact of the pandemic. And there's a lot of these things at the macro level, but the micro level, 3 things are clear that we've seen. One is there's a skill shortage, right? So we've heard other folks talk about skill shortage. Just curious, how many manufacturers here have experienced issues around skill shortage? Okay. 5, interesting. Okay, and then supply, so the one stat around that is that by 2030 in North America, 2.1 million manufacturing jobs will be vacant, similar in Europe, with more than 500,000 jobs currently unfilled. That's kind of hard numbers to wrap my head around personally. The second is supply chain disruptions, which are continuing, right? Making it harder to get products, making it harder to source parts and new equipment. And the cost of goods continue to rise. We see this at the consumer level and also at the industrial level. And there's a lot of, the good news, there's a lot of uncertainty, but the good news is that it also creates opportunity. Let's see if this will play. Yeah. So in a static market, right, incumbent suppliers are next to impossible to displace, right? If everything's going fine and you're just keeping on the status quo, and a company has been using, this product for years, they're not really going to change. You need a disruptor to change course, right? And many of your products might be that disruptor. So every now and then we experience this major event, right, that change the natural order of things. So those that can adapt the fastest become the new leaders. So we believe that right now is the time, right? It is an opportunity to reimagine possible and change to do things better. So for manufacturers like BBI Racing, which was in this video, finding a way to control costs, maintain margins, manage supply chains, upskill people, and attract young talent means they're better positioned to win market share today and tomorrow. So when we say reimagine possible, we see this as the opportunity to take advantage of trends, right? So one trend is smart products. This makes the machines around us more productive, also creates opportunities as customer demand grows and product developers expand and supply chains onshore. So one example of this is like sensors that read off machines, sensor hardware that connects to robots or, the FANUC controllers, right? This IoT system around our manufacturing floors. Secondly, manufacturing processes are being increasingly digitized, which provides greater flexibility and efficiency in the tools that we're using. And third, cloud technologies are changing how we manage our supply chains and the manufacturing processes, helping deliver products on time, every time, right? This is where an MES system, ERP systems come into play. Oh, I forgot to go around. Oops. Yep, I'm just gonna move a little faster here. So despite all of these demands and these opportunities, right, we're seeing most of our customers still using old and antiquated experiences where they're having multiple softwares with incompatible file formats, poor data control, with files being shared surprisingly still via email, wasteful manual processes, disconnected workflows, and a mix of digital and analog information. This is nearly impossible to avoid, right? There's a slide I didn't put in here, but I'll describe it to you briefly. It's basically a digital maturity chart. Maybe some of you have seen versions of this, right? So, at the bottom, or at the first level, right, there's basically companies using paper, right? Who still uses some paper? Let's be honest. Yeah. Every company I worked for used paper. And then at the other side of the digital maturity level, there's like fully cloud connected, instant data across, digital twin across your entire factory, from at every location where you have real-time data about, every worker, every machine, everything that's down, every maintenance assessment, everything. You know how many customers are at that level? Any guesses? Yeah? Like almost none, right? It's a nice goal, right? But we're not doing this because we need to get there today or tomorrow, right? The idea of digital maturity is that every step in the process is not just important because you're getting to the next step, but is an outcome in itself, right? The advantages gained from incremental improvement in processes is huge. Like, okay, you're all on paper, but you digitize this one area. Maybe it's, inventory tracking. Just doing that is huge. So the goal of, this slide showing the chaos of all of the different file formats, right? Even if you get a few systems to talk to each other, that's huge for automation, that's huge for benefit. So this is not to say we shouldn't all aim for, tier 4 or whatever of digital maturity. We absolutely should. But we should, be both realistic and practical in what we actually can achieve today, this year, in terms of increasing our business outcomes towards automation. So, as manufacturers, we need to address challenges and aspire to 4 key values. And this is, at Autodesk, we're really all about outcomes, right? Like, what are our customers getting? So we want them to create better products, win more business, improve operational efficiency, and enable increased innovation. And you all probably have your own unique challenges, right? No company is the same. But one commonality we see is the need to automate to speed up manufacturing processes and reduce delivery times. And that's why we're all here today. Now, what do we mean by automated? So when I'm talking about automated for this presentation, within the manufacturing industry, it comes in many forms, right? Assembly lines, industrial robots, we heard a lot about that today, to automated guided vehicles, right? But for this presentation, I'm focusing primarily on software. Autodesk does not build hardware products. And we're trying to help automate the processes for manufacturing. And the goal of that being reduce non-value added tasks, deliver repeatable and consistent workflows, improve quality, reduce human error, and result in more reliable products. So we're going to approach manufacturing from 3 levels. So first is the machine, right? So here we're talking about individual conveyors, gantries, mills, lathes, et cetera, on the shop floor. And we'll talk about automating setup, programming, and inspection tasks using a variety of machines. The second level is the operations of a factory or shop floor as a system, right? System of people, a system of goods, all moving through space. And here we're concerned with increasing manufacturing throughput by optimizing processes around production management. And the final, and that's this one. And the final level is supply chain. So securing the materials that you need for manufacturing without compromising quality. And here, this is part of a MES system, streamlining the management of inventory and suppliers. All right, so let's start at the machine level. So in a recent survey by the Modern Machine Shop, more than 400 US-based manufacturing businesses were asked to review their achievements in 2022. So a number of interesting statistics stand out. First is 28 days. This is the average time taken to go from initial receipt of order to completing a project and delivering to the end customer. 80 minutes is the claimed average time spent setting up a machine in readiness for processing a new part. This includes fixturing, tooling, positioning, etc. 65%, this is a typical machine utilization across the year, meaning machines that are non-productive for 35% of the year, right? This is similar to some of the statistics.
That's incredible. That's a survey data coming from that person.
Yeah, that's, yeah.
When you actually measure that,
It's even less.
that's the 28%.
Yeah, so as reported by people, they said it was 65% utilization. Clearly they were over-reporting. But interesting that they did over-report. That's some sort of psychological, maybe they didn't want to look as bad as it was. 10% is the typical business growth rate. Bigger would be better, right? 9% profit margin. 45% is the claimed typical order win rate. And 40 is the average age of employee in the manufacturing sector, with the average employee having 12 years of experience. It's interesting, there was a question much earlier about employees being sort of green recently, someone sitting back there. And I was thinking about this number. 40 seemed lower than I thought it would be, to be honest. I'm curious, does anyone else have any reactions to that number or any numbers on this slide? Did you have something you wanted to say? No. I was a little surprised. So at this point, I want to introduce Fusion, which is our flagship cloud product for design and manufacturing. So it's not just a PLM system or PDM or MES or CAD or CAM. It doesn't just focus on milling or additive or fabrication. It's all of those things. It is packed with powerful tools to streamline product development and manufacturing, from initial product design to simulation to documentation. It provides a comprehensive toolkit for every piece of a product development cycle. And the part we're going to focus on today is the NC code generation and some of the automation tools around part manufacturing. So, I'm going to walk through some examples of some of the individual features. It's a little bit more technical, but I think there were some other technical things, so I think this is a good audience for some technical demos and features around it. So these, I'm going to give 4 or so. These mostly are focused on CNC machining, which I think some folks in the room do, but we also have not shown a lot of features around, for example, nesting and fabrication for sheet metal and things like that, and also injection molding simulation. So not what I'm going to show today, but they're there. So the first is automating setup time. So on that slide I showed, 80 minutes was the reported average setup time for a part. So starting with setup, right, Fusion can automate this piece. So it includes workpiece coordinate system probing using spindle-mounted probes, and we can add surface inspection and part alignment capabilities to monitor the quality and performance of the entire CNC machining process. So basically, you can probe your part before you start, entirely automated, and then you can add probing cycles in the middle of your CNC, programming of your program, so that you're actually checking and monitoring the part before it's done. So, for example, if you do it after the first operation or the second operation and it's very much out of alignment, maybe your fixture wasn't tight or something, you can realize that, scrap the part before you get, 2 hours into the machining time. So all of that can be programmed. And here is a little video. So so here we have a comparison between manual and automated sequences on the same part. So in the top video, you can see the time is actually moving a lot faster in the top video. But in both cases, it's the same part on the same machine. And by programming the setups offline and running them as quick, repeatable, and accurate NC programs, you can maximize profitability. You can use that time for other value-added tasks. And you're getting more accurate probing. So the automated setup took 2 minutes and 40 seconds, and the hand programming setup, and this video was done with a experienced CNC machinist, and it still took him 15 minutes. So this is a pretty awesome feature I've actually used myself to program parts when I was an engineer. And this is using templates. So I'm going to see if this video will cover it. But the idea here is that you can create a template. You're basically doing similar operations for similar parts, right? You might you might, for this turning part, you're going to run some roughing operations, some finishing operations, some grooving operations. And that's a pretty templatized, set of operations already. So you just create, that list of operations in a file, right? And then you drop your part into that file. It finds the part, and it applies all those toolpaths to this part. And if you want to do it to a second part, you just drop that part in, and it does the same thing. It applies all of it. So what that allows you to do is not add the same toolpaths over and over again as you program multiple parts. It's just literally a drag and drop, and it automatically figures out what it's doing. And it does that by figuring out what to cut by subtracting the part from the stock. So it's totally automated. And it's very repeatable. It makes for more consistent parts. It means you can get new employees up to speed doing more complex parts faster, right? If you have new programmers coming in and they're getting up to speed on the software, they're getting up to speed on what toolpaths to use. Here you have an experienced person creating a template for a part like this. They drop it in, and they can start cutting much faster. The second one is around hole and pocket recognition. So when I was an engineer and I was prototyping on CNC machines, this is something, is pretty ubiquitous. I did it a lot. And every time you have to click on the holes and size the drill. So this automated tool, basically, you select the part, it finds all the holes in the part, and it finds exactly the sizes. It suggests tools for you to use for those holes, and it will do it. You'll basically select a face that's normal to the vertical axis. It's going to find all the holes on that surface. So this works for models imported from their CAD systems. It recognizes holes using predefined configurable templates. So you can, once it recognizes all the holes, you can say, okay, do you want to use a template? And let's say you have a template for reaming, or for spot drilling, or for tapping, right? You just say, okay, I'm going to use this tapping template, and it will apply that to all the holes or some portion of the holes. So it really reduces what was a quite manual process into a couple clicks. Did I play that? I think I did. Yeah. So then we have automated whole part machining. So I talked a little bit about this, but this is a huge benefit. I wish I had known about this when I was machining parts. So this is we have a lot of strategies in this category, but basically they eliminate the need to select edges, faces, features, etc. to machine. You just select the part, and it calculates what to cut. There's roughing strategies for this. There's finishing strategies for this. Probably the most automated one is this toolpath called Steep and Shallow, and it works for shallow pockets or shallow surfaces and really deep surfaces, or steep surfaces. So typically you'd have different toolpaths for like milling flats versus milling, the edges of pockets. And this allows you to use one toolpath for all of it. You just basically have a threshold of like, above a 90% angle, you use this toolpath. Below, you use this toolpath, and it's still one toolpath, but it's pulling in the code from these other strategies all into one. It's pretty awesome. We also have things like automatic deburring, automatic flat machining, where it finds all the flat surfaces. So just these little things, and remember, these are not things you have to program every time. They're things you could just templatize. So you have templates for different parts with all of these automated strategies in them. You drag and drop parts into them, and they practice. With a few tweaks, you're basically having the machining and the programming time done in a fraction of the time it would take. And then the last thing is collision avoidance. So this is probably most useful for multi-axis machines, but still fairly useful if you're have complex fixtures, or you're thinking about hitting the limits of your table of the machine. So it can program simultaneous multi-axis operations. You can put the machine in and have it detect collision and figure out how to tilt the part, not just to optimize the toolpath, but also to eliminate those collisions. So pretty sweet. This is has been a big area of focus for us, is not just building like world-class CAM software, but building in these automations so that we can have the best toolpaths done much quicker. And all these features work on a platform that is designed to converge, or have design and manufacturing converge. We use a single manufacturing data model. So anytime you're making a change, that's available to all stakeholders instantly. So for folks who've used Fusion, it's a cloud-based platform. So if I change a toolpath and then I save it, it also automatically saves. It'll be available to folks viewing that code instantly. So it's super quick. If you're going from programmers to operators, that's almost an instantaneous connection. They can leave comments on the file. They can suggest edits. You can have multiple viewing levels, so you can have like read only and store things on a common platform. It's pretty powerful. So now that we've covered that, any questions about automated programming? Okay.
I haven't heard you say CAM.
Yeah.
No, I haven't heard you use the word.
Oh, I used it when I was introducing Fusion, I think. But yeah, it's CAM. Yeah. I'm not avoiding CAM. Yeah. Okay. So I'm going to move on to talk about digitization at the factory floor and supply chain levels. So I'm going to cover mostly around digitization of the factory floor. Supply chain is a small piece of it that I'll talk about at the end. So there's no doubt that manufacturing or managing a manufacturing or production facility is difficult, right? Balancing production and profitability goals with customer expectations is challenging, right? And we find that our customers are constantly faced with obstacles that can impede their path to being successful. Delays in supply chains, workforce, right? We talked about all the things, short lead time, expectations, and the critical piece that can transform these obstacles or get over these obstacles is data. So being able to make critical decisions flexibly, right, with access to real-time production data is pretty important. And Bill talked a lot about that earlier, right? So here's a typical production workflow. I'm going to try to step through this and sort of lay out the landscape for what are the different types of systems that you can have. So typically there's this is a typical production workflow. So at the start of the production process, a work order is created, right? Then come various stages such as procurement, various operations that are need to be done to produce the order depending on the complexity, right? But how is it started, right? How is it started? How is information moved? And how is production tracked, right? These are questions that we ask our customers in discovery calls, like what is your current situation? And the typical production workflow, looks like this. So, most common way of managing information on any production floor is typically the paper traveler. So, you receive a client order, data is input in Excel, the order code, the products produced, how many, when they are due, right? This document is then printed out, given to a supervisor to start production. It follows the production flow along with the manufacturing materials. Each operation is recorded by operators on the shop floor and then returned to the back office team for manual data entry once that step is completed. We see this all the time. So going back to our workflow, we can see that the paper traveler moves the production information along with each stage. Sometimes it's literally like on the order, under the order. So as it travels, right, information is written down, timestamps are recorded, it tells us when each stage is complete, right? And then when the whole job is completed, the package is returned with the information production filled out, ready for manual data entry. There are several issues with this, right? We know that. First of all, you're relying on a person to manage the initiation of this process. You can't just say, okay, work orders in the system, start. There's this whole, printing, figuring out, like making sure all the numbers are right in the sheet, then relying on that person to go physically take it down to the shop floor, which for small businesses might be literally right outside the office, but for larger businesses might be a different location entirely. Might be, down the road. Maybe those people are connected, maybe they're not. Maybe they need to email it. Things get lost, right? So operators, and the other issue is that operators are inconsistent with how they record their work. Data can be difficult to read. Things can be spilled on it, like just simple stuff like that. And in real time, the production manager will need to physically traverse the shop floor to understand their status. Our customers will get a call, hey, what's the status on my order that I put in 3 weeks ago? And the person answering might say, I don't know, I have to check with our production manager. They have to go track them down. They have to go find the sheet. They have to go find out who's working on it at that time, right? No real-time visibility. This can be challenging if you want to look at, how has our performance been the last 2 weeks? How's our throughput been? How many jobs have we completed? And even if the traveler is filled out perfectly, we still have lots of missing information, right? Things like inventory, operational availability, uptime, downtime, supply chain management, quality management. So at the very beginning, we might have the right material in stock, but maybe maybe we made some errors in the machining process, and now we're out of stock. Where is that being recorded? How is that being connected to the production process, for example? And what about operational availability? What are the machines currently doing? Are they down? Do we know why they're down? Are they running at capacity? What about the workers, right? A huge piece of this is the workers. Are they available? Are they working on their jobs? So one person asked the question earlier about how do we track worker productivity? Like, how do we know which of our employees are working at, 110% of their expected capacity and which ones aren't? That's also important. You want to make sure that if you have workers that are struggling and they might not self-report it, you want to be able to say, okay, here are some, maybe you need help with this, maybe this is an opportunity for upskilling, et cetera. Like, to be able to identify that gaps is pretty important to retaining workforce and retaining skilled workforce. And what do we do with all this information that's gathered, right? If we do gather it, if we do have it, it has to be manually inputted at the end. This is a bummer, to be honest. No one wants to do data entry, right? No one wants to take a huge stack of papers about a whole job order. Maybe it's pretty complicated. Maybe it's months long, and then someone has to input it into some system. if this doesn't get done, then, maybe there's accountability for it, maybe there's not, but if it doesn't get done, there's no data on it. And even if it does get done, like there's a opportunity cost in the timeliness of it, right? We need to know what's happening on the production floor in real time. So using traditional methods, when information is required mid-process, someone has to find the person. But there is another way of tracking production, right? We've seen this a little bit, which is Excel, or less frequently Airtable, or just homegrown table-based systems. This is digitized, I guess, in the purest definition, but it lives in isolation. It's unstructured. It maybe was built by someone 20 years ago, and it doesn't really offer a lot of intelligence or visibility. It's just a recording device, basically. And we found that, of course, there's paper, there's spreadsheets, there's whiteboard systems to track their processing. These all have high costs. They don't provide information. They don't enable manufacturers to be on top of their processes, and they don't do a good job of achieving business outcomes at all. Deadlines are missed, increased waste and scrap, reduced quality. So there's a better way, and one of our products, which is called ProdSmart, which is an MES system, and I'll go into that in detail about what that actually means, primarily aims at digitizing production processes, giving key analytics and intelligence to make better business decisions. So one difference, one differentiating feature of ProdSmart compared to machine metrics, right? So we don't currently have any or have connectivity to the machines themselves. All of this is worker initiated. It's not recorded by typing. It's all a system of scans. So the way this works is it's an app. It's cloud-based, similar, but it's more focused on the worker and the user versus the machine. So, of course, we track machine uptime and downtime, and that's based on scanning in and out. So a worker gets to a station, they scan in, then when they're done, they scan out, and we take all that data, and that's how we calculate uptime and downtime. It also gives us really detailed analytics on each worker themselves. So, the basis of the platform is the users. So that's a pretty big difference. And I'll talk about the benefits of this system and some more stuff after. But first, I'm just going to walk through the capabilities. So first, some definitions. So when we think about the elements within an organization that need to be monitored for manufacturing, or in design, actually, you might get something like this. Like, these are all pretty key elements. It's not exhaustive, but it does highlight the vast amount of data that needs to be controlled and monitored in a design and manufacturing business. So because of all these elements, we look to software solutions to help manage all this data. So the definitions are, and hopefully this is helpful in this broader conversation, right? So we talk about PDM, PLM, MRP, ERP, and MES, right? So PDM is product data management, and that's a system that centralizes product-related data and processes. It's really for engineers to track revisions, manage change orders, generate bills of material, and more. Oops, I forgot to do the last one. It's mainly on the design side, although I have seen some folks use PDMs, or some customers use PDM systems for some of the facilities management stuff, like keeping track of drawings around, building plans and, machine data sheets and things like that. PLM is product lifecycle management. So this is a system used to manage the product lifecycle from conception to sampling to production. It's a collaborative solution that brings together data, people, processes, all to aid an organization's ability to develop products, right? So think of it, if PDM is just around, sort of the data management or the file management, PLM is around all of the process management that surrounds the data management, right? So, okay, you have a change order. What is the flow for that change order? Who does it go to? Who approves it? All of that is captured within PLM system, plus more. MRP is material requirements planning. system for calculating the materials and components needed. It often consists of inventory control, scheduling production, purchase orders, etc. So ERP is a very big one. It stands for Enterprise Resource Planning. And these are typically huge, expensive systems. They're very comprehensive, and I'll show what they typically include. But they consolidate all aspects of a business, including customer relationship management, or CRM. So like, for example, Salesforce is CRM. Purchasing and accounts, human resources, material requirements planning, supply chain management, and a lot more. And last but not least, there's MES, which is Manufacturing Execution Ecosystem. Manufacturing Execution System. So this monitors, tracks, and documents the controls the process of manufacturing goods from raw materials to finished products, and uses data to provide information on production. So it's really specific, typically, to production. So this is what it looks like visualized. So going back to the elements diagram. So this left side is really on the design side. So we see things like data management, BOM management, NPI, which is new product introduction, design collaboration, design review. This is all PLM, right? PDM is a small portion of those. PDM would include like design collaboration, design review, BOM. But PLM is really the system around it that involves all of those processes together. And that's on the design side. And then we see on the manufacturing side, we have an MRP, right? That's just one piece that I talked about. And then all of those, but it could also include elements such as production, scheduling, and material purchasing, and all of that is typically within an ERP. So ERPs are huge. They typically are not great solutions for very small businesses because they just are expensive, and they really consolidate a lot of things that in a small business might only be like one person doing it. It's not like a whole department or anything. But what MES systems do, or MES, is they take a piece of ERP that's really only around production, and they do it well. Like, so they really focus on that production piece. And the primary functions are to manage manufacturing execution, production scheduling, manage materials, and monitor quality. So this is where we're gonna focus on for our solution, although we do have a comprehensive solution for PLM and PDM, which is on that other side of the diagram. So when it comes to manufacturing software solutions, like we just mentioned, all of those different acronyms, which becomes an alphabet soup very quickly. Those are used to digitize paper. They tend to work better for larger organizations. They were built for companies with large budgets. They were built with companies with dedicated IT staffs and integrators to figure out how all the systems work together, right? So if you have an ERP system, for example, you need to put a bunch of stuff in one bucket, right? You might have a CRM, you might have a change management system, you might have an HR system, and for that to all integrate together is quite a big task. And typically, it doesn't get you a lot of immediate benefit. It takes a long time to implement. And even MES systems or MES solutions that are pieces of that, if they're built for larger organizations, they can take a lot of time. And of course, they're quite expensive. But we see from our research that it takes 6 to 18 months to implement a typical enterprise level MES solution. So with ProdSmart, what we're seeing and what we're hearing from our customers who adopt is that it's really fast. They can get up to speed in a matter of weeks. We've seen 2 weeks from purchase to full implementation. We're also pretty affordable. It's a scaled pricing model that is based on the number of users, but for like our mid-tier size, it's less than $1,000 per user. And it's efficient, right? Easy adoption by management. You get dashboards, you get data analytics instantly with a modern digital interface and device independence that goes on an app. So I'll play this quick video.
Operating a production facility can be complicated, with a constant need to monitor everything from raw materials through to finished goods. To help address the challenges,
Should I pause it?
production managers look to manufacturing execution systems, or MES, to track their production processes. But often these can be expensive to set up, painful to integrate, and under-deliver on addressing their true needs. Autodesk ProdSmart is different. ProdSmart is a go-anywhere, use-anywhere, cloud-connected MES and light enterprise resource planning system, which capitalizes on the use of web browsers and mobile devices for operation. This minimizes the IT overhead needed to get you up and running sooner and gives you the flexibility to start managing your production data today and adapt to your business as it grows. Focus on what's important, like monitoring your operations through production tracking dashboards and audit-ready quality compliance reports fed by real-time information collected from the shop floor, making it easy to visualize your production efficiency all the way from orders to shipping. Manage your teams, machines, and materials to optimize your production capacity and increase manufacturing throughput with material and resource planning, helping to minimize waste and reduce the environmental impact of your business. With scheduling for preventive or corrective machine maintenance to reduce production downtime. And integrate with upstream or downstream resource planning, customer relationships, and product lifecycle management systems to keep your data synchronized and prevent duplication. So, whether you need to improve your production workflow and execution, cope with change and quality management, or get visibility on throughput and machine maintenance, get your business future ready with Autodesk ProdSmart.
Yep. So ProdSmart, in its simplest definition, transforms floor production into a digitized process. The main objective is operational efficiency. So we want to help manufacturers and fabricators and empower them to go paperless by digitizing and automating their operations. So we help schedule, track, trace production and quality processes in real time with data and capture data on the shop floor. So it's a cloud-based modular tool. It's super flexible and it has really quick implementation time. There's also, instant data capture available, on the dashboard as soon as it is input via scan. And the scan is all done on standard devices, tablets, smartphones, etc., as well as barcode and QR readers. It does not currently do machine monitoring or machine level analytics, but it does have the ability to aggregate different data sources and feed those into the system. And there's multiple benefits, right? So the ability to increase manufacturing flexibility, getting necessary information to plan ahead for the next production run, how to improve supply chain agility, minimize production waste, with no complexity, no IT team required, no extensive hardware needed. We don't have to come to your facility to help you set up things. As is, it can be implemented. You just go to your browser or mobile phone, sign up, install the mobile app, and you can start obtaining results and data. Digitization, data-driven decision-making, and automated production monitoring. So, today we talked about Fusion and ProdSmart, but these are just two of our products that we feel are on the leading edge of digital transformation and automation in manufacturing. Our whole portfolio can help you, capitalize on trends, increase operational efficiency, and grow business. One I will mention that I didn't talk about explicitly today, which is our factory planning suite. So it is, what I talked about at the beginning with how Autodesk products can help from designing things, making things, designing places, and building places, right? We have a workflow that has amazing interoperability going from none of the products I mentioned today, but Inventor, Revit, to Autodesk Build, which is our construction cloud, where you can basically, starting in AutoCAD, you can lay out your factory floor in AutoCAD. You can add the assets in Inventor to create a 3D design. You can send those 3D designs to Revit, which is our architectural software, and in there you have your you'll have a model of your building, of your factory. And then you take that model into our construction cloud. You get to see, on your iPad as you're walking on the site where things will be, right? And the final piece of that is a software called Navisworks, which is, we call it 4D, which is where you as an avatar get to walk through that digital model of the space, of the machines, of your factory before it's built. So you can see if there's any collisions. For example, will a large duct interfere with a robot arm? You'll get to know that. Will my conveyors fit through the door? These are all things that have been caught early in this factory planning workflow. So I didn't even talk about today, but that's a pretty powerful workflow that we see a lot of companies use. So yeah, I'll stop there, and yeah, here's my email. Feel free to reach out, and I'll hang around a little bit after if folks want to talk, but love to take any questions. Yeah.
What market does ProdSmart focus on? Like what, is it fabrication, or where do you see most
A variety of industries. We're seeing, it was a fairly recent acquisition, so maybe a year and a half ago. But we're seeing customers all across, like there's not one that has like stood out as where it's like, oh, we're getting over half our customers from this industry. We've seen food and beverage, we've seen apparel, we've seen industrial machinery, we've seen everything. So it's pretty interesting. I think that there's still, we're still waiting to see sort of what industry rises above the rest since the acquisition, but right now it's everywhere. Small medium businesses everywhere. Yeah. Yeah.
From a previous employer, we used to use Inventor with SAP as an ERP, and I remember that interaction was difficult, was painful. This was years ago. So I'm hoping that this new advancement makes it to import just version control and all those things. And
We're using Vault?
yes, and we hired an integrator. I remember we hired an integrator. There was a third party involved in Switzerland because it was a Swiss company.
Yeah.
And yeah, it was a challenge. So I'm hoping that these new improvements makes it a little bit more. Yeah.
Yeah. I haven't used that workflow with SAP, so I'm not sure, but I believe you. Other questions? Sleepy end of day.
Yeah, end of the day. It's been a long day.
Yeah.
Thank you so much. Appreciate it.
Yeah, you're welcome.
All right.